students. After the discussions of previous topics like basics of kinematics in the previous class, today we'll discuss briefly about displacement, speed, acceleration, and what are their dimension and what are their units, all these things. As you have come to know that motion in a straight line is a part of kinematics, and I also told you what we study in kinematics and what we don't. As you know that kinematics is a branch of physics where we deals with the motion, position, direction, displacement of a body, but we don't deal with the reason behind it. That's so simple. And there is another branch of physics, that is dynamics, where we deals with the region of the motion, force of direction, displacement of all these things, which led to the Newton's uh, laws of motion. That we have got the three laws of motion. That is in the next chapter in dynamics you'll come to know. So on the previous class we left on displacement, and today we'll come to speed in our discussion. What is the speed? I just told you, but still I am going to discuss it briefly today. What is the speed? Speed is nothing but it is displacement, a distance crossed, distance traveled in unit time. Okay, you write down speed is defined as, it is defined as, speed is defined as the distance traveled in unit time. Distance traveled in unit time. That is the definition of speed. You please note down that speed is defined as the distance traveled in unit time. How it is expressed? It is expressed as, speed actually sometimes we give it by p or s. V is equal to x by t. V is equal to x by t, where x is the displacement, t is the time, and p is your speed. That is the mathematical expressions of speed. Speed is defined as p is equal to x by t, distance upon time. It has got the unit, its SI unit. Its SI unit is meter per second, and CGS unit, that you know, CGS unit will be centimeter per second. That is all about speed. Understand? So speed is defined as the distance traveled in unit time, that is expressed as v is equal to x by t, and its SI unit is meter per second and CGS unit is centimeter per second. Understand? So in this case, if you want to find out the dimensions of speed, you have found in the previous chapter. Dimension of speed, how to find out? The dimension of speed we'll find out is equal to, it is distance by time. Distance means we'll give you L, that is L, and times means you T. So this is equal to, we can find that LT inverse 1, or if you write m power 0, L power 1, T inverse 1, that is the dimensions of speed. Understand? It is all about speed. You need to know that it is p is equal to x by t, that is x is the distance and t is the time. These are their units, meter per second, and these are their units, centimeter per second in CGS and SI respectively. Dimensions you can find out, p is equal to L by t, L for distance and t for time, hence you can write like that. That was your speed. Speed is independent to the direction. So you can say that speed, if you want to say that speed will be what, a scalar quantity. Speed is a scalar quantity because it is free of direction. Understand? Na? So speed will be defined as the distance by time. Next, if you write down the velocity, what is velocity? Velocity will be defined as velocity. Velocity, it is defined as, how will be defined? It is defined as displacement, rate of change of displacement, rate of change of displacement, rate of change of displacement. It is defined as rate of change of displacement, and it is expressed as, velocity will be expressed as same v is equal to displacement. Again we'll have again you can say displacement as s by t, where s is the displacement, t is the time. Displacement, the identification of displacement may be varied. Sometimes maybe x, maybe s. It depends upon the yourself how you give it. It doesn't matter actually. So this is your velocity. Velocity is equal to displacement by time, and its unit will also be what? SI unit. SI unit is meter per second, and CGS unit will be what? Centimeter per second. This is all about the velocity. And in this case you can say the dimensions of velocity will also be same with speed. Dimension of velocity. How to find the dimension of velocity? Dimension of velocity will be found as, again, it is LT, that is your displacement, LT times. So I can directly write m power 0 L power 1 t inverse 1. That is the dimension of velocity. So that is all about speed and velocity. I think you have cleared very nicely about these two topics now. Understand? Next, we have told you in the previous class about motion. So what is motion? I told you that if a body changes its position continuously, or if a body keeps changing its position continuously, then it is called a motion. There are two types of motion: uniform motion and non-uniform motion. We have studied all this thing and you know, so I am not going to explain it again. Understand? Distance, displacement we have discussed. One more thing to discuss, that is average speed. What is average speed? You might know average speed and average velocity. You should write average speed. Average speed will be defined as the total distance traveled in total time. Understand? Na? Average speed, it is defined as total distance travel in total time. It will be expressed as, if I give this p bar will be your average speed. Am I clear? P bar will be your average speed, and this is capital X by capital T, where capital X is the total distance and capital T is the total time taken. Am I clear? This is your average speed. Average speed means you're defined as the total distance traveled in total time. And how it is expressed? That is v bar is equal to x by t. So unit will be similar as the speed only. Average velocity will also be defined by same category. That average velocity will be defined as total displacement in total time. That is average velocity. Total displacement in total time. You can write average velocity. Average velocity, how we define? It is, again you'll write, it is defined as total displacement in total time. Total displacement, it is defined as total distance travel, total displacement covered in total time. So it will be expressed as again V by, that might be S by T, capital S by T, that is your displacement, average velocity. Understand? Na? Just one more thing. In this case, we have to discuss instantaneous velocity. Instantaneous velocity or instantaneous velocity is another topic for you, that you should understand what is instantaneous velocity. For that, we have to go to the uniform motion and non-uniform motion. Motion I told you, uniform motion also I have told you. Am I clear? So if I consider a straight road like that, suppose it is a straight road and that has taken as I have given them as XY. So from X to A, from X to B, from X to C, I have given some point in this particular straight line. Now in this case, if you consider from X to A, that is your 100 meter, this is also 100 meter, this is also 100 meter, and this is also 100 meter. Say to travel this distance of 100 meter, it takes 10 second time. Again 10 second time. Again in this case also 10 second time, and here also 10 second time. Understand na? Total distance is X to A between 100 meter, between A to B is again 100 meter, B to C is again 100 meter, and C to Y is again 100 meter. Now time taken in this to travel this distance will be 10 second, in this also 10 second, here also 10 second, here also 10 second. So if I consider the motion or motion in this case, or if I consider how is from time taken to travel, time taken how many, sorry, if I, that is 10 meter, 100 meter in 10 seconds from X to A, between X to A. So you can see as this is 10 100 meter, and how many time? 10 seconds. So it is, what is the speed of it? 10 meter per second. Again similarly from A to B, how much? Again 100 meter by 10 seconds, how much? 10 meter per second. Again from B to C, it's also similar, it is like that, so it will be what? 10 meter per second. Again from C to Y, it is 100 meter and 10 seconds, so it is what? 10 meter per second. As you can see, they are traveling same distance in same amount of time. Equal distance, in this case, equal distance in equal amount of time. So if they are traveling equal distance in equal amount of time, they will be says uniform motion. I have told you, but I have brought this topic for another concept. And if it is traveling equal amount of distance in equal amount of time, this will be called as uniform motion. But somehow if it doesn't travel or does not travel equal amount of time in equal interval of time, equal amount of distance in equal amount of time, then it will be told as non-uniform motion. But why I have brought this topic in order to understand instantaneous velocity. Okay, instantaneous velocity. You can write instantaneous velocity. What is this instantaneous velocity or instantaneous speed? And it will be defined as the amount of distance travel. Instantaneous speed you can write. So instantaneous speed, if you write instantaneous speed, to make you understand this topic, instantaneous speed, I have again brought the concept of uniform motion. Remind it, otherwise we have discussed it. So what is instantaneous speed? We can define as, now you can see that how many, it is 10 second, how many time has been taken to travel 100 meter. We have taken 10 second time. Similarly, in this case also we have taken 100 meter of 10 second time to travel 100 meter. But if you are asked that how many distance it will travel at 9 second, suppose at 9 second, how many distance will travel at 9 second, then this amount of speed will be known as instantaneous speed. That means distance travel in a given particular time. You can write distance travel in a given particular time. In a given particular time is called instantaneous speed. Am I clear? So it will be expressed as V is equal to somewhere delta x by delta t. That is your instantaneous speed concept. Distance travel in a given particular time is called instantaneous speed. What is instantaneous speed now? That I am again telling you, I am repeating these things, that you can see that from x to a distance is 100 meter and time taken to travel this much of distance is 10 seconds. That means you are sure that in 10 seconds it will go 100 meter. But if I ask you how many distance will be traveled in 9 seconds, how many distances travel at 8 seconds, suddenly if you ask, that is called instantaneous speed. Suppose I am traveling, I am walking right now. If you ask me what is your position right now, that is instantaneous. Actually we can say right now. If you ask currently, on spot, that is instantaneous speed. So I have given that distance travel in a given particular time is called the instantaneous speed. Understand now? So these are basic formula of kinematics you should know. Again, we'll move to the acceleration now. Acceleration we all have studied in class 9 very briefly, and in my introductory class also I have given some hint about acceleration. You write acceleration. Acceleration, how it is defined? Acceleration is defined as, write down, it is defined as rate of change of velocity in unit time with respect to time. Velocity with respect to time. Am I clear? This is called acceleration. Acceleration is defined as rate of change of velocity with respect to time. Remember, now velocity might change in positive order also, and velocity might change in negative order also. And if it is changing in positive order, it will be acceleration in positive, that is acceleration only. And if it is decreasing as changing, then it is will be known as retardation or deacceleration. We have got this concept in class 9th or 10th. So it is expressed as, you can write it is expressed as a is equal to v minus u by t. What is v minus u by t? V will be your final velocity and u will be your initial velocity. So final velocity minus initial velocity is your change in velocity. That is your change in velocity in per unit time or with respect to time. So a is equal to v minus u by t. That is the acceleration, and it has got an unit, and its unit will be what? Meter per. That is you know what is the unit of acceleration. We can say that meter per second square. It is its SI unit, and CGS will be centimeter per second square. All this thing you know already. Now if I go to find out the dimension of it, dimensions of acceleration. Dimension of acceleration. Acceleration dimension will be found as like that. If I find the dimensions of acceleration, so we know this is velocity. Velocity has got we know what is the dimension of velocity. You have already found it, or you have already studied in the previous chapter of unit and measurement. And you can see this is velocity and time. For time we can say this second. For time it will be second. Just you should know that velocity. Velocity is what? Velocity is equal to, we know, displacement by time. So displacement upon time. Displacement upon time means it will be like that. Displacements will be L, and times will be your that is LT, or not. For time it will be T only. So you have come to know in this case that in the previous chapter how to find the dimension. This is LT. So if I write, it will be what? LT inverse 1, or not. It is the dimension of velocity. Velocity has got the dimension LT inverse 1. So if I write here, this is LT inverse 1, and in above, below it will be time for t. That means total we can find this is LT inverse of 2. And if I write, this is m power of 0 L power 1 t inverse 2. That is the dimensions of acceleration. I am not going to discuss briefly about these things as you have discussed in the previous chapter. So this velocity will be displacement by time. Displacement will be L, and time will be t itself. So it is LT inverse 1. And in this case, if I find the acceleration dimension, it will be LT inverse 1 by t. So LT inverse 2 m to the power 0, L to the power 1, and t power minus 2 is the dimensions of acceleration. Is that clear? Now one more interesting thing about acceleration, that when acceleration is supposed to be negative and when acceleration is supposed to be positive. Am I clear? Write down. Acceleration may be positive, may be negative. That means if the amount of change in velocity is increasing, then it will be what? That is positive acceleration. And if the velocity, amount of change of velocity is decreasing, that will be your negative acceleration or deacceleration, or you can say as retardation. You have studied, understand? So what we found, that formula of acceleration. Acceleration is defined as, we found a is equal to v minus u by t. That is the definitions of acceleration we have already found. Understand? Rate of change of velocity or change of velocity with respect to time. If final velocity v is greater than u, remember, if final velocity v, that is a very important point. If final velocity v is greater than u, then acceleration supposed to be positive. Acceleration is positive. Acceleration is positive. Have you got it? If the final velocity is greater than initial velocity, then acceleration is positive. Understand? Understand now why it is so? So you can say if p is greater than u, we can write that v minus u is equal to what? It is a positive integer. Positive integer, you know these things, you will find in mathematics casually. If the final velocity is greater than initial velocity, then acceleration is positive. Okay, if p is greater than u, so we can write that p minus u is equal to a positive integer. Understand now? This is the positive acceleration, or you can say acceleration. So if I give an example of it, if I take an example of it, suppose a freely falling body, if I take an example of freely falling body, suppose that is a body falling freely. Am I clear? This body is falling what? Freely. A freely falling body. A freely falling body would be example of positive acceleration, because once this body will start falling towards the ground, this will be the initial points. Initial velocity will be what? 0. At the beginning, initial velocity of the body in case of a freely falling body will be 0, but once it start coming towards downward, at the main point, the final velocity will be what? Maximum. Understand this point? For a freely falling body, we can observe or we can experience the positive acceleration. As this body at initial point, the velocity will be 0. As it grazing towards the downward, and then the what? At the final point, velocity will be maximum. That means in this case you can say that final velocity will be greater than initial velocity, hence that is the positive acceleration. Understand? If we go to the negative acceleration, so it's very simple. If initial velocity is greater than final velocity, then acceleration is supposed to be negative. That is, negative acceleration is retardation or deacceleration. You have studied. If u minus v is equal, u is greater than v, so I can write that v minus u will be a what? Negative integer. Is that clear to all of you? If u is greater than v, so v minus u will be a negative integer, hence the acceleration will be negative. If you take an example of it, what will happen? If you throw a body from the ground, suppose you are throwing a body from the ground, you are throwing a body upward. If you throw a body upward, what will happen? At the final point, the initial velocity will be what? Maximum. That means you are throwing. When you throw a ball, that means a projected body. If you project a body upward, then what will happen? That at the beginning of the projection, the velocity will be maximum. But as it go towards up, then at this point, the final velocity will be 0, hence the body will fall down. That means you can say that in this case, what is happening? That u is greater than v. That means initial velocity is going to be greater than final velocity. That means you will feel in this case retardation. That means or deacceleration. That is how we can define negative acceleration and positive acceleration. Understand? You go through it, and it's a very important thing. In the next class, we'll discuss more about it with next topic. Till then, thank you so much.